Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, and we are in the process of time series modeling, and that too the structure of bar modeling. In the last lecture, we have discussed something called as unit root, then cointegration, and then the structure of VAR. We have specifically highlighted what is the structure of unit root and the kind of cointegration. Once again, I am just connecting to the unit root and then move to cointegration and finally the VAR setup. So, the structure of unit root start with autoregressive scheme like this. So, where y t is connected with y t minus 1, and we are supposed to check actually whether A is statistically significant or not. So, this can be tested with without any constant and trend. We can test with a constant and we can test with constant and trend. So, that means every time there are 3 different ways you can test the unity root. So, the Dickey-Fuller test is like this, and we have to check whether the particular coefficient is statistically significant, and you can go ahead with this simple OLS technique and then derive the conclusions. Okay. Then if it is actually statistically significant, then you will start with rejecting the null hypothesis that the variable is actually non-ternarity, and ultimately the variable will be ternary. If not, then you will regress the model with first differential equations, and as a result, so we have here 3 forms. The first one is with no constant and trend. So, that means we have simple start with the variable. So, here there is a constant and here there is a constant and trend. So, whatever may be the forms, ultimately the end result is the statistical significance of these parameters, the coefficient of y t minus 1, and that brings the nature of the ternarity and the order of integration. That is by this simple Dickey-Fuller test. So, again I am not going in details, and then you like to check actually whether the variable is ternarity or not, and if it is ternary at what levels, and again in what forms. Is it with pure random walk without drift and without trend, and again random walk with drift, that is what the constant, and then random walk with drift and trend, that is the dealing. So, the ADF is just extension to the DF by addressing or adjustment with the log length. So, likewise we have another test called as Phillips-Perron test, and some of the structural change may happen. So, in that case the best test statistic which you can apply is called as a Andrew-Zivert test, and Andrew-Zivert test will give you some kind of a structure to carry out whether the variable is reaching ternarity or not. So, now what will you do here? So, we will just check the behavior of the variables and bring whether the variable is reaching ternarity and at what forms, right. So, after that we will move into the concept called as cointegrations. Let me bring into the cointegration concept, because the concept of unity root we have already highlighted in the last lecture, and the cointegration starts with simple regressing y upon x, provided this system starts with integrating y and x. So, for instance, let us say there are 2 variables y and x, and we like to know whether y and x are co-integrated each others. There are various methods are there, starting with simple to complex. So, we can actually use the simplest form of the model called as Engle-Granger approach, EG approach, or you can apply simply called as Johansson-Gieselius approach. In the Engle-Granger approach, which is actually simplest way to know the things, it has a two-step process. That is why it is called as Engle-Granger two-step cointegration test. The first step is to check whether y and x are related to each other. So, we start with regressing, bring linear regressions and that too through LS technique, and then check whether beta coefficient is significant and get the estimated equation, and finally get the error terms, which is in difference between y and y head, and we need to check whether the particular error term is actually teснarity or non-teснarity. That is the step 2 process. In the step 1 the coefficient should be statistically significant, and in the step 2 the error variable should be teснarity in nature. If that is the case and we will have it, then we declare that y x are cointegrated to each other. That is the declaration we will have, and that is the need through which you can actually proceed for the vector autoregressive schemes. So, what will you do actually? So, this is what we call traditional approach. Then even if we can use cointegration regression by Durbin Watson, that is technically called as a CRDW, and then we will go for by simple Engle-Granger approach, what I have already highlighted. Okay. So, this is a step by step process, simply regress y upon x, then get the residuals and check residuals teснarity, and that itself will give you the indication about the entry to bar setup. And technically we have also different test structure called as Johansson-Gieselius. It depends upon it is again it is a kind of vector format, and like here when we are using Engle-Granger's approach or CRDW. So, here it is a kind of simple form. We just regress y upon x and then derive the error term and then check the teснarity of the error term. But in the Johansson-Gieselius approach, we are supposed to you are supposed to bring actually the kind of vector forms where we have two different test statistics through which you declare the cointegration. That is the structure called as trace statistics and maximum eigenvalue statistics, and on the basis of trace statistics and eigenvalue statistics, we can declare whether the variables are cointegrated or not. In the Johansson-Gieselius approach, so if you look for the kind of cointegration, then with respect to two variables, so there is a feasibility of two cointegration or one cointegration or say no cointegration. So, technically whether it is a one cointegration or two cointegration, there is a cointegration, and if not, there is no cointegration. So, now the VAR structure specifically needs the kind of inference about the cointegrations. So, technically in the VAR setup, if you go to the VAR setup is like this. So, we like to know what is the linkage between y and x, whether unidirectional, bidirectional or simply neutrality, and we can test these hypotheses through simple VAR structure, or if not then the VM structure. So, that itself differentiate with the help of cointegration. So, that means technically the issue of VAR is like this. Technically it will be like this. So, for instance, let us say y and x, and we call it yt and xt, and then we start with VAR setup, and then there is called as VSM setup, vector autoregressive, which is actually the core of this problem, and then the other form is called as ECM, that is the first VAR, and then ECM is the error correction mechanisms. So, that means there is error correction term which will derive, because the usually the error terms UT is entered as error correction terms by bringing the form called as UT minus 1, and then as usual the VAR models, and then we introduce the error correction term, and then again you go for the estimation. So, here you need to check the coefficient of the error correction terms as well as the coefficient of variables. The coefficient of the error term will give you the long run signal, and the coefficient of the variables will give you short run signal. So, ECM involvement means, so there is a indication that cointegration, but that cointegration may not be actually in the long runs. So, now in order to know whether there is a long run kind of inference, so the ECM term will be, error correction term will be integrated with the VAR setup, then the model can be turned into vector error correction model, and then finally you have to estimate and test the kind of structure. So, accordingly that is what the actually structure. So, accordingly we can see what are the things we are supposed to discuss. So, the usually most of the financial data or time series data, any engineering time series data, basically actually you can say that financial engineering, most of the variables is having actually time spread, and that means informations are available with respect to different point of time, and this kind of model is very easily useful there, like arch model and gauge models and autoregressive and moving average. And then we will like to check the kind of inference. There is lots of history behind this VAR setups. So, we can actually simply skip this, and then we can bring into the kind of structure where we can have the requirement. Okay. So, the VAR form is actually start with a simple again Wallace mechanism. Because the structure of VAR model will be like this, you see here y t as a function of alpha plus summation delta j y t minus j plus mu summation mu j x t minus j equal to 1 to p, let us say j equal to 1 to q, let us say, and plus error correction term ECT t minus 1, that's, and then error terms, another error terms, that is what the model is all about. And here this significant, so we can put it here actually, let us say lambda, the coefficient to error correction term, and we need to check whether this is statistically significant, and in addition to that whether the coefficient of mu j is statistically significant. So, this brings that x t is influencing y, that too in the short run, and this significance of the terms to y t brings the long run impact. Okay. So, likewise you can develop another model for x t same way, and again you have to check the coefficient of y t here and the error correction terms, then the given signal that it is the y t which influence the x t. So, that means technically with two variables we have two different model, one with respect to y t, another with respect to x t, and then check separately and come into the conclusion that whether both the models rejecting the true null hypothesis to justify that x is causing y and at the same time y is causing x. If that is the case, then you can say that there is a bidirectional causality. If only one happening, the other one is missing, then it is called as a unidirectional causality, and both are missing completely, then it is called as what we call as neutrality happenings. So, the thing is that it is tested with two variables only, but in the meantimes this can be extended with multiple variables. So, that means the structure will be, let us say 3 variables, we can start with like this you can start with like this in a say y t, okay, let us say y t, x t and z t. Okay. So, now again the structure will be here, y t starts with the y t minus j, then x t minus z, and then j, z t minus j. So, that will be another variables to be added into the system, and then as a result we have 3 different models like this. So, now you like to check x t upon y t, z t upon y t against, while where we are targeting the first equation, that times x t minus j coefficient, z t minus t coefficients will be these variables of choice to predict the y, and again when we integrate with the x t and y t as the reference and z t is the reference, then that times we targeting whether y is influencing x and z is influencing x again. So, z t is the reference variables where we are linking x t upon y t. Of course, z log of this z t will be there, here log of the x t will be there, and here log of the y t will be also there, and then check whether x t is influencing in z t and y t is also influencing z t. If that is the case, then we like to check how is this kind of linkage. So, that means we have a multiple options here compared to bivariate case. In the bivariate case, we have specifically 4 different situations: unidirectional y to x while the reverse is not true, then again unidirectional x to y, the reverse is not true, then bidirectional where both can go each other, and neutrality they do not cause each other. That is what the kind of concept. But in the case of trivariate here, so we have actually 3 such combinations, y x, y z and x z, and again we have 4 different specification under each groups. So, technically, so if for 4 different kind of inference in each group, so technically we have a 12 different kind of inferences which we are supposed to be checked and get to know how is the kind of setup. Ultimately, the VAR requirement or VAR structure is just to know whether the particular variables are interdependent to each other, and that too in a time series framework. It is slightly different to the ordinary linear regression model, even though we are using here Wallace mechanism. There also we are using Wallace mechanism. In that case, we are just integrating y t upon x t and z t. So, y t cannot be another variable, independent variable there, and all are independent. Just we are regressing x t and z t with y t, that is the 3 variables there in the process. But here the case is slightly different. Here of course, there are 3 variables, but by spread with log, so it can have n number of variables. So, y t minus j, x t minus j, then z t minus j. Again we have no clear idea how the j will vary, is it with respect to 1 or with respect to 2, with respect to 3. The moment you start 1, 2, 3 log, then model spreads will start increasing, and that brings simple model to complex models and simple structure to multivariate structure. Even though we are starting with VAR, still this model has lots of complexity and the kind of extension. So, obviously, since there are lots of logs involved in this process, by default we need to first optimize the log length. So, optimum log length is the first hand choice in the VAR setup, and that is how the idea is to see how to choose log length. That is the big deal. So, we have already discussed the choice of lag length in the case of Arima cluster, Arch cluster and Gauge clusters, and where we have actually specifically highlighted that there are certain statistics. These includes AIC statistic, SIC statistics, finance prediction error statistics. These are the statistics are also equally used here to optimize the lag length, and that is the first hand criteria of this process. Once you do this, then obviously by default you can fix the lag length first, and after fixing the lag length, then you come to a kind of conclusion that a model is specified, correctly specified, and then look for the kind of causality inference. For instance, the model starts with at least one lag first. It cannot start with 0, it will start with 1 lag, then it can start with 2 lag, it can start with 3 lag, 4 lag and so on. So, that means we have lots of flexibility here. We have lots of flexibility here. The same inference can be checked with respect to fixing lag length 1. Again, you can check these inference with fixing lag length 2. Again, check the inference by fixing lag length 3 and so on. If your sample size is indefinitely very high, then you have lots of flexibility to enhance the kind of models. For instance, if you go to the problems Excel sheet which you have already highlighted earlier, you will find Excel spreadsheet where we have already used some kind of analysis for the unit root. So, now in this case see for instance, the simple VAR modeling, and what we like to do, see let us say INF is the dependent variable here, then it will be regress with the INF t minus INF with INF is t minus 1, then OL t minus 1, provided inflation and oil oil consumption 2 are in the kind of in the basket. So, now the inflation can be predicted with fast behavior of inflations and the oil consumptions, that too fast behavior of the oil consumption, with the intention that the lag of these variables will influence the current performance of inflations. Then your if you fix lag length 1, optimum lag length 1, which we will actually finalize with the help of AIC and SIC statistics, and then you just regress now INF with INF minus 1 and oil minus 1. Again you go simple regression mechanism and regress and check the inference. Of course, if we use VSM, then first you actually bring the error correction terms by linking actually inflation with oil, then get the error correction term, okay, and the lag of the error correction term, which is actually instrumental in the VSM process. Okay. So, that means technically if you bring VSM, then another variable will be added into the system in the form of ECM. Then ultimately you are supposed to check the coefficient of oil and the coefficient of ECM. The coefficient of oil will bring the short run impact of oil to inflation, and ECM will bring you long run impact to the inflations. And in the similar fashion, this will be the kind of this will be the kind of structure you can follow dependent variables, and that can be linked with INF t minus 1 and oil t minus 1 and then the error correction term. Since oil t minus 1 is the dependent variable, so the target variable will be inflation t minus 1, that is the short run impact to the oil, and then the kind of error correction term, the coefficient error correction term, which is actually long run impact to the oil. Then you check the kind of behaviors. Now, if you try to extend the log length, let us say you are not happy with one log length, you can go for 2 log length or 3 log length. Of course, we like to fix on the basis of AIC and SIC statistic. Still you can actually test. So, in that case, let us say if you are fixing 2 log length, let us say INF is the original variable, then you have INF t minus 1, OL t minus 1, INF t minus 2, OL t minus 2, and then error correction term. That means, technically you have 5 set of variables to this particular system. So, that means, you just imagine if you start increasing log length, how is the complexity of this estimation and the kind of model. But it is the means that itself is the beauty of the VAR system and vector autoregressive system. And by the way, these are the requirements through which actually you have to predict the kind of some of the engineering variables, because the behavior of a particular engineering variables in a current form or the requirement of the future form exclusively depends upon its past behavior. That is what is actually represented by the log structure, which we are actually observing here. And after knowing the particular structure, then you can use any software to check, but theoretically you should first convince that yes, the log variables import is there in the current performance of these variables, then you can actually start. So, every time the issue starts with theoretical understanding, because it is at the end of the day it is all about econometrics. So, theoretical hint and logical hint is actually mandatory to start this process, otherwise it is a simple mathematical operation only, which we can do easily. But the thing is that since it is a kind of application oriented and looking for a solution to a engineering problem, so you should actually in the first hand convince that this theoretically there is such kind of linkage and evidence, and then through this technique and data you empirically verify and bring the reality, what is exactly happening on the basis of theory, and that too what data reads about it, what model speaks about it. That is what the kind of structures. So, that means technically I like to highlight that VAR is a kind of structure which is very interesting to carry out some kind of inference, and in response to VAR model and vector error correction modeling, which we can quantify and then we can test in a kind of quantitative framework by checking the coefficient of these variables and the coefficient of the error correction term. And by the way, we sometimes use actually the kind of chi-square test to check the validity of the models. Okay. But in response to the estimation process and the check process, that means hypothesis testing. So, we have two different form for which you can justify the reliability of the VAR model or VSM model. That is called as impulse response function, that is graphical inspection about this model estimation, and variance decomposition schemes. So, through a impulse response you like to check how shocks in one variable gets transmitted to other variables over the time. That is actually through impulse functions we can derive, and then usually the typical size of the shock is actually should be greater than 1 standard deviation of the innovations which is generated, and plots of these impulse response function for the policy shocks, and that too it is equivalent to some kind of simulations, right. So, the variance decomposition scheme, it reflects that what fraction of the forecast error variance could be attributed to the one and the other variables. That means, we are linking actually let us say y t with y t minus 1 and then the kind of x t minus 1 or z t minus 1. That means, so what is the on influence that variable if you starting with y t minus 1, that means the variable on behavior is also reflecting the current form, and then the other variables log will also influence that the variance factor and the forecasting structures will be derived through variance decomposition schemes. typically it converges after a few steps, and if this is the case, then we can actually get to get to know that the reliability of the model and some kind of robustness we are bringing. So, the we are just ordering the innovations, complete the ordering leads to a triangular decomposition, and then finally, the impulse response functions would depend on this particular ordering. So, these are all actually different kind of setups through which justify the importance of the VAR modeling and their reliability structure, and ultimately end of the day we like to justify that the VAR model is a reliable model through which actually we can forecast certain engineering problems, and that too with the availability of some time series informations. Until unless you have a time series data, you can bring into the log forms, and then we cannot use actually VAR modeling. Even if all the time series modeling starting with the autoregressive, ARIMA, ASGAS and the kind of VAR, every times your first hand information should be a time series structure. If that is not the case, then you cannot use these models for any kind of engineering prediction and forecasting, and then you cannot come with a kind of decision making situation. So, the first hand requirement is that you must have a clear cut understanding about the problems, and must have variables clarity how the present past form can influence the current form and the future requirement, and then must have availability of time series data, and that too in a long span, and that's what the strength of this particular these types of models. If your time span or the variable information is not so good enough, then these models, I mean all these models cannot be very handy to predict certain things as per the particular requirement. With this we will stop here. Thank you very much. Have a nice day.